Well, good afternoon from the East Coast of the US. Uh, so, good afternoon, good morning, good evening, depending on where you are. I welcome you to our webinar today. My name is Nick Dewhurst, and I'm going to be presenting today with Brian Rapoza to show you guys the new features in DFMA 2023 that we will be releasing very shortly. So just a couple of logistical things before we get started. The webinar is being recorded. Emails will go out to you, I believe it's 2 hours after the session ends today, with links to the recording. The GoToWebinar control panel, you can kind of shrink that if it's in your way. There's an orange arrow in the upper, it's a white arrow on an orange background in the upper left-hand corner. If you kind of shrink that to the right, it'll minimize that on the desktop so you can see more of what you're doing. I do have my resolution dialed up a little bit so that you guys can see my screen a little better. And then just logistically, as we go through this, if you do have questions for us about something, there's a questions section or a questions feature. It's in the GoToWebinar control panel. So if you click the little arrow next to questions, you can type in there a question for us. The reason that I'd like you to do that is we'll try and answer them in real time as we're going through the webinar here today. But if for some reason we're unable to, or just gets too hectic with presenting and answering at the same time, those questions will be logged and we can get back to you via email after the presentation today. So again, please don't use the chat feature, but use the questions feature to submit questions to us so you can, so we can get a response to you. So why don't I just jump right in and get started here with what's coming out. So right off the bat, I'm going to show you a new tool that we've developed. We're calling it the DFMA dashboard. And then I'm going to showcase some features in the design for assembly software, some features in the design for manufacture software, and then Brian is going to get more in depth with a new feature that we're introducing into the design for manufacture software to help you get better results more quickly. I guess I'll let him, dig into the details of that when it's his turn. So if I start the new software, I'm going to click the start button. I'm running Windows 11, so it might look a little bit different than you're used to. This is I've got both the release version and the new version. So when you install the version of the software 2023, we've simplified what's in the start menu. You can now run the design for assembly software, you can run the design for manufacture software, or the thing that we're trying to get to be sort of the hub of where you start all these things from now is the dashboard. So if I run the dashboard, this is what it's going to look like. So here's my first showing of this to the larger public. And it's a sort of tiled interface that's going to allow you to customize this dashboard to be able to do the things that you want to be able to do with the software. You'll notice there's some buttons up here at the top that we're going to come back to a little bit later. And then we have these tiles here that define different things that I want to do. And then over here on the right-hand side, I've got this option to manage these tiles. And so if I open this up, and when you install this by default, by the way, this will be open so you can see what's in it. These are all of the other tiles that you can turn on in this interface. So the idea here is that you make this yours. The things that you work on frequently or that you do frequently with the DFMA software are things that you can enable on this list and have quick and easy access to them. By default, we're going to have the design for assembly software and its recent files shown, and the design for manufacture software and its recent files shown. If you routinely are editing data in our material libraries, I can just click this button here to turn on the DFM material library choice. You can see I now get a tile for that. And if I click it, it'll come up and say, well, what library do you want to open? Let's open the North America one. And then I could do some work on that material library if I wanted to. Again, the same things for the other libraries here. And then let me turn that one back off. down here towards the bottom, you can see we put in some more utility type things. So the license manager is in here. I can turn on a tile to check whether my software is up to date or not. I can get quick access to the online software tutorials. I can get a quick way here to email technical support. And I can have all of these on this kind of dashboard view to help me, use this the way that I want to use it. Now, if you want to reorganize these tiles, if emailing tech support is the thing you want to see first, I can drag that all the way up to the top, and I can reorder these and put them in any order that I want to really home in on a custom view of how I want this to look. So that's one of the features of this dashboard, and we'll come back to it as we get deeper into this and show you some of the other things that you can do. But on the right hand side there, you can turn on and off the tiles for any of the things that you want to be able to see or display, and you can move them around to put them in any order that you want to have them in. Next, I'm going to open up our Design for Assembly software, the Product Simplification 2023A release. And so if I click that tile, you can see it runs that for me. And I'm going to open up a completed analysis here. So I'm going to open my friend the motor analysis. You're all probably familiar with that if you've watched our webinars in the past or gone through any of our tutorials. And I'm not going to get into the details of anything associated with this now in terms of its actual analysis, but I'm going to point out a couple of the things that we've enhanced and added to the Design for Assembly software. So right over here on the structure chart on the left-hand side, you can see we've added the option to include line numbers. Fairly simple thing. It's been requested by a number of you in the past. If I go to this view menu, I can enable or disable that. So if I turn it off, they just go away, or if I turn it back on, they come back. And it's going to be a nice way for you to be able to talk a little bit more easily about the parts that are in your structure. So if you're in a group and you've got a couple of people using laptops looking at the same thing, and you're talking about, the set screw, well, which set screw are we talking about? Well, it's line number 9, and it helps me just quickly figure out which parts we're talking about more easily amongst the group. Now, the big change that we've incorporated into DFA, and you may notice it here, or you may not if you're not paying close attention, is that we have included the custom user data library feature that we included in the Design for Manufacture software a year or so ago, so that you can now add your own costs to an assembly analysis to roll up I'm not going to say a better total, but a different total. And so you can see over here on the right-hand side in this response panel, there's a box here that says custom totals. We've got the unadjusted total cost at $49.22, and that's what's coming from the software. And then I've developed a custom user data library here that's calculating a shipping cost and a profit cost to give me a adjusted cost here of $54 for the total cost of this assembly. So where does that come from? Well, if I go to this libraries menu, you can see here we've added this custom user data option. If I select that, it will run this custom user data library window. This tab right here is what in the old software was called the custom user fields. So if you want to add a field to track the supplier or track the delivery date of a part, that all still works the same way, and those custom user fields are defined here. Now we also have the second tab here, custom user product costs, and this is where you define you use the operation library code effectively to calculate any additional costs that you would like to include under this custom user data library umbrella. And so you can see here I've made a simple operation. It says that profit is the profit margin divided by 100. I want the user to type in a percentage there times the total product cost, and then I have this very simple made up formula of shipping being 0.05 times the total piece part cost of the assembly. And I can define as many of these costs as I want, and I can define them however I want to define them. And I can have multiples of them. So if I actually choose this open option here, I can open other custom user data library formulas that I've defined. So I have another one here for this demonstration that's just calculating a profit. So here you can see it's not calculating a shipping cost, just calculating a profit cost that I might want to add to my totals. And so with all that being said, if I close this window now, that's where I create them and where I edit them and where I save them as these custom user data libraries. And then what I have to do is tell my Design for Assembly software which one of those libraries I want to include. So I go to the libraries menu, I select librarian, and in the versions that are currently released, you have an operations library and an item library. Well, now we have this third library, and it also includes the option to just use the standard DFA results. So if I choose that and say okay, and then I reload my library data, you'll see now I'm not including any of the custom costs. That's gone away, and I just have a cost total. If I go back to that librarian and I select the one that's allowing me to calculate profit only, and then I reload that library data again, I'll do it for both of these, then I'll get one that's only calculating the profit, right, per that operation that I just showed you. Now we have a total cost of $51.65, and then again, back in the library operation here, I'll add the profit and the shipping one. It maintains a list of the ones you've used recently, so you can switch back and forth between them in that drop down very simply. I'm only having to reload this every time because I'm changing the custom user data library. Now that this one is assigned to my software, this custom user data library will be added to any analysis that I do. So if I do a file new, I'll get these things included unless I go into that librarian and tell it to just use the standard DFA results. So, nice, simple interface with an exciting feature that now allows you to add any of these cost adders that you want to include in your assemblies, much like we had done for the Design for Assembly software. The information is now also carried through and displayed in all of the reports and graphs. And so if I go to my results menu and I choose, let's just say this DFMA totals, and I'll include the tooling cost, what I'll see is a print preview of the DFA totals report that looks very similar to ones that you're seeing currently, except down here we have the addition of the custom cost totals. Now this is a totals report, so it's showing the total cost inclusion. And I can, again, like I have in the past, add additional columns here, and it'll show me the before and afters, and then I could get it to compare them and show me the cost differences. So my redesign is a 45% cost savings, and I can see the reductions in total costs that are being achieved as a result of those changes. If I want to see the individual contributions to those cost totals, I wouldn't look at the totals report, I'd look at the cost breakdown report. And I can look at that as a report, or I can look at it as a graph. So let me show you here the cost breakdown graph. And when I bring this up, you'll see that shipping and profit are now included as bars. If I had 2 or 3 or 4 of these custom cost totals that I'd added through the custom user data library, they'd be included on here. And again, I can compare these with one another in any of these different graph formats, right? So I can stack the bars, I can look at them as pie charts. And if I go back to this individual bars one and I bring up the actual printed version of the report, well, now I get the cost breakdown graph, and then I get the details of that, the assembly process cost, the manufacturing piece cost, and then as you see here, the shipping and profit calculations to give me the total. Then I can compare that to any different redesign options that I've included or not included in the software. So that's how those are the sort of the custom user data library there, and the line numbers on the structure chart are the sort of 2 main changes. We've made some bug fixes. We've added the option to display the handling and insertion difficulties on the redesign view. There's a bunch of little things that are included in this as well, but the custom user data library is really the main feature that has been added to the Design for Assembly software in this release. So if I switch back to the dashboard here, and I'm going to switch gears and look at the design for manufacture software. So I'm going to run that from my dashboard here. You can see, by the way, that list of items in the dashboard, the software remembers your last 5 analyses. I've been loading versions of this software, so I haven't done more than one since this morning when I loaded this latest version. But if I included, if I'd done more work, I could have up to 5 of these displayed and 5 of these displayed in here as well. So your most recent files would be right on the dashboard here as well. So here's our DFM tool. This is the 2023, again, release. I'm going to just quickly do an analysis of a plastic part. So I've got this plastic lever here that I'll load a CAD model of so that we can see what it is we're doing an analysis of. So you can see here, this is the part. The software has done its thing and extracted the envelope dimensions and calculated the thickness. And now I select a process and a material, and you can see here that I, like before, can say I want to injection mold this, and I want to do it from ABS, and I'm going to choose the North America profile. And when I say OK, I get a cost result that comes from that. Now, a couple of things that we've done in the DFM software. First of all, it has a fully updated material library. So the information associated with the materials, and more importantly, the material costs and the scrap values of the materials have all been researched and updated. If I go to the manufacturing profiles choice, I actually want to delete both of those because I didn't want them in there. The software will ship to you with these 2 libraries in it, like it has before. You see there 23A North America and 23A China. We did get some additional information that allows us now to sort of with more confidence include costs associated with materials in China that are different from the costs associated with the materials in North America. In the past, we didn't have good clarity into that. With some additional information now, we've been able to update those, and I'll show you some of those differences on the graphs when we get to it. So all new material library with all up-to-date information. The other thing that we've changed is we've made the way in which you can include manufacturing profiles and data associated with them easier in the software. So I've created a few additional profiles, and I've already given it away because you saw what they were in my librarian there. But if I go to this manufacturing profiles choice, this is where, historically you would have said new. I would have called this new profile. And then here I have to browse to the individual libraries that are associated with each of those profiles that I want to create. Well, that seemed like a not such a great way to do it. If you want to follow the convention that we have now for how we store our libraries, we create a folder in the DFMA libraries directory, and that folder in this case is called 2023A. And within that, we have all of the libraries associated with that manufacturing profile. And so now if you create your own folder and put your own libraries in it, you can create your profile simply by choosing this add feature. So if I say add, it brings up a slightly different looking dialog than you've seen before. I can choose this. I have mine stored in my documents DFMA library directory. And when I do that, you can see all of these are folders that contain library data. So I had created a profile for India. And so you can see here my 23A NPD DFM India. If I click that and say OK, the software just creates a manufacturing profile for me based on library data that's in that folder. So I don't have to go and browse them all individually. I could have, browsed to someone else's folder and very quickly made that. Now it does have all the checks in it to make sure that I'm picking information that's correct. So if I say here add again, and I go to my documents, DFMA library directory, and I try and choose this one that I've craftily called here not complete, When I say OK to that, you can see, well, that folder doesn't have a material library in it. And it says, try and pick a different one that has that information or include that information so you can go forward. And I could come back and browse to a different one, or if I say add again, which is what I should have done there, sorry. And then I go to this DFMA data library directory, you can see I'm going to add this one because we've now taken the ability to define libraries in different currencies and associated that with the profile. So I've created a manufacturing profile here for costs in India, but all of those costs are in rupees. And so if I say OK to that, it adds that for me. And again, I can see all the libraries that I've created. And if I say OK to that, it's going to, update the software and validate that everything's OK. And now I can make use of those new libraries that I've created. So I'm going to call this here USA, and then I'm going to copy this and paste it, and I'm going to create a few versions of this analysis here so I can show you some of the differences. So if I select a process and a material here now, I can choose China, and I'll say ABS and OK, and it'll recalculate the piece part cost for me. And then I'm going to copy this again and paste it, and I'm going to rename this one to India. And I'm going to select a process and a material here, and I'm going to choose India, and I'm going to say OK. And then finally, I'm going to copy it one last time just to show you how this is all working. And this is going to be India, and I'm just going to put that at the end of it here. And I'm going to change this to my rupee profile and say OK. And now what you'll notice is on this last one that all of my costs here are now in rupees. And so if I go into this injection molding, you can see here my material cost is in rupees per pound for this particular material that I've chosen. And so the cost structure is now associated with the profile, and I can now have tabs within a file that are using different currencies, and the software handles all that for me without issue. Now, one of the things we had to change in order to make that work was how the graphs and reports worked so that they could be compared or not with one another. And so if I go to the results menu here and let's start with the US one, and I look at this cost totals graph, what you'll see is it shows me what you've seen currently, but you can see over here on the right-hand side, it breaks out the different cost units for me. So if I want to compare the US and China, I can do that here because both of those are defined in dollars. But if I want to compare the US with the India that was done in rupees, I can't do that currently. But what I can do is I can go to the graph menu and I can choose change currency. And I can tell it here, this drop down will build as I put the different currency units in it. And so if I want to see the results in dollars, I can tell it that there's about $0.012 per rupee. And when I say that, you'll see now this changes to analysis cost units converted to dollars, and I can compare them with one another here so I can see the differences. So we tried to think through what people might want to do with these things and give them the options to understand and include them however they want. The same thing is true and runs itself through the reports. So if I go to this totals report and just take a second here to build that, it'll come up and show me the totals for the US. And then again here, you can see it's showing me I can select it, but it won't put it on the same page. It'll give me a different page with that result because they're non-compatible currency units. However, I can uncheck that. And again, I have the option here to change currency, see my results in dollars, and I can change that to $0.012 per rupee again. And now when I include that, it'll put it on the same graph for me, and I can baseline the US against India in rupees, and I can see the cost differences in dollars and percentages associated with each of those changes. So for our international users, I hope that's a change that's going to make some difference for you. You can create libraries in your native currencies now and then very quickly compare those back to other currency types that you want to through the use of those change currency options at the reports level. So Brian is going to detail some other pretty significant changes that we've made to the DFM tool in a minute. I just want to go back to our dashboard for a minute here and show you a couple of other things that we've included in this that I think that you're going to be excited about. So in addition to this tiled interface to get in and out of the different software programs and utility kind of features from here, we also have, you'll notice here, an option to say open. It's fairly trivial and easy what that does. It brings up the file open dialog box, and it's got a bunch of different types that you can choose here. So the default is DFM and DFA files, or DFMA files. So you could browse wherever you want to open a file, but we also have the different library types in here if you wanted to open up libraries from within this open dialog. So that's fairly straightforward. The thing that I'm really excited to announce and introduce to you here is this new search function. So for a long time, our software has been not the easiest thing to find old analysis files for us. And we've had recommendations that you save file names as part numbers, and then you could use the Windows find features in order to do that. But now we've put search capability into this dashboard tool to allow you to find things and filter things and really get access to the details of the data that you have created. And so I've got one defined here that is going to search for DFM files on my OneDrive. And I'm just going to go ahead and click that, and then we'll build another one together to show you how it works. So if I say search here, what this is doing in the sort of 3 or 4 seconds that it takes to run this search is it's gone out to my OneDrive and it's looked for all of the DFM files. And so you can see here I've got a fairly extensive list of DFM files that are on my OneDrive. But not only has it found the DFM files, it's actually opened every one of those files and extracted a whole bunch of data from them that it's presenting to me here in this kind of spreadsheet-ish view. And so if I scroll across here, you can see it's got the file name, the created by date, the date modified. But then as I move further across here, we've also extracted the piece part tooling costs, the total costs, the manufacturing processes, the materials, the profiles, and then the breakdown of material setup, process reject, and tooling costs that contributed to those totals. Now, if I wanted to say no more about this analysis here, I can click it. And over here on the right-hand side, this file details, I can click that little option to fly that out. And it shows me all of that cost data in a vertical view here. It's a little bit easier to see than having to scroll across. If I click on this one, you can see here, it'll show me those results. And then if I want to see that analysis, I should have closed this at first. I can simply click the open button here and it'll open that file for me. And then I could work on it and see what it was that I wanted to do with it, or however the process worked. So you can find a whole bunch of files, click one, click open. You can also choose copy here, and it will copy just this information for that file. You'll also see over here on the left-hand side that we have the option to export these results to Excel. And so if I make that selection, it will export whatever data it has extracted here into an Excel spreadsheet for me and allow me to see that particular data. So if I make that a little bit bigger here and then I do that, so you can see this file name, and then as I scroll across here, all of this information has been extracted and is presented to me here in this Excel form, and then I could copy and paste data. I could put it into reports. I could run different analytics on it to compare them to known costs in spreadsheets I had for bills of materials. Sort of the world becomes your oyster here with what you could do with this sort of stuff when you found it. Now, what makes this a little bit more exciting, I think, in addition to these things, is we also have the ability to define multiple ones of these searches. So I can drop this down and go to untitled search 2 here, and let's just call this Nix DFM files. And what you can see here is I can browse again to a folder location. So I'll just stick with my OneDrive here looking for DFM files. And if I want, in this layout option, I can choose which of these column headings I want to include. So let's include the file location this time as well. And then you can turn on or off any of these different things that you might want to turn on or off. But then this is kind of the neat part that I'm excited about. We have this filters choice. And so I can add different filters to filter the results. And so if I just click search now, that was doing what the other one was doing, and it's showing me all of the DFM files on my OneDrive. But now if I add a filter to this, I can filter on any of these different criteria. Any of these different criteria. So let's say I want to filter first on manufacturing process. And now it gives me a list of all of the different manufacturing process choices. And so let's say I'm only looking for injection molding analyses. And then I want to add another filter, and I can say where the tooling investment is, and I've got some choices of operands here, let's say greater than 10,000 as a number. And then I could even add another filter if I wanted to, and I could filter on, let's say manufacturing profile, and let's say is North America. So that's going to now find on my OneDrive all of the files that are injection molded with greater than a 10,000 tooling investment and using our North America profile. And when I click search, you'll see this list becomes shorter as a result of that. And if I wanted to, I could, again, extract any of that data, see it. I can sort here by tooling investment in descending order, or maybe we want to sort by piece part cost in descending order. And so now that's how this is shown to me. And if I were to export those results to Excel, that's what I would get. So those filters you can have as many of them as you want to refine the data more fully, or I could add a filter that, let's say, where's part number is on here somewhere, I think. So like that 2388, let's say I know that's a part number I want to look for. So I'll search for part number, and let's just put 238 in there, see if it finds it. I'll click search, and it'll find anything that has part number 238 and then anything else in it associated with it. And so now I've got those three parts. I can look at their details. I can export it to Excel. I can do any of the things I want to. So I can build up those searches however I want to build them. I can search across cloud drives, network drives, anything that I have access to find data that's out there. And then the final thing I'll show you here is once you've defined those searches, you have the ability to include them here on your home screen. So there's the search of my OneDrive DFM files that I showed you. And then this is the one that we just built together. And it tells me here there were 3 results, and I last searched it today. If I click that now, it takes me to that search result. If I click this one, it takes me to that search profile, and I can do the search to do it. So once they're defined, you can set them up on here, searching for DFM or DFA files, and very quickly and easily get to those searches to find the results or parts or data that it is that you want to get at. So that's it for my portion of this. I'm going to stop talking now, turn the reins over to Brian, and let him speak to you about some of the additional changes that we've included in DFM. I'm going to go ahead and do that now. And before I make him the presenter, I'll just remind you one last time, if you do have questions for anything that I've covered here or anything that Brian's about to cover, please go ahead and use the questions function in order to supply that. And Brian, I believe you are now the presenter, and if you want to share your screen, we should be good to go.
Okay.
I see your information and we're ready to go. Yeah. Thanks, Brian.
All right. Thank you, Nick. So my name is Brian Rapoza, and I'm the Director of Engineering here at Boothroyd Dewhurst. And I'd like to talk a bit today about a new feature that we're adding to the next release of the DFM concurrent costing software. And this feature is called dynamic costing. So dynamic costing is a dynamic sensitivity analysis of the important cost drivers for a manufacturing process. And our objective with dynamic costing is to only display the most important primary software inputs for the specific part that you've analyzed. So it really enables you to focus on the most important cost drivers for your specific part. And this can be helpful because it enables you to optimize your time and effort when you're estimating the cost of parts. And really, that's useful in just about any situation that you'd use the DFM concurrent costing software in. So some examples, if you're using the software for early product development work, so every little piece of information about a part, it can be really difficult to get at that stage of development. So identifying the most important cost drivers for your part, it lets you spend your time more effectively while you're still getting very good and useful cost estimates. And also, if you're doing something like supplier costing work, and you have 100 different parts you have to analyze in a very limited amount of time, identifying the most important cost drivers, it lets you focus on getting very good cost estimates while minimizing the amount of time and effort that you spend doing that. So our objective with dynamic costing is to save you the time and effort while minimizing the impact on your cost estimates. So all cost estimates have an error band that's associated with them. And the cost models that are built into the DFM concurrent costing software, they're no exception. So when our cost models are initially being developed, we test the results like shown here on the left. And this is actually only a really small sampling of comparisons for a typical cost model. So it's been trimmed way down just to fit on the slide and be understandable so you can get the point here today. So usually there are hundreds of these types of comparisons that are done to test a cost model. And sometimes there's more than that. But the end result is what's shown here on the right. So when you analyze a part in the DFM software, there's an error band that's associated with the results. And that's shown here by these red error bars on the graph. So generally, our cost models have a plus or minus 10 to 15% error band associated with them. That's what we kind of find acceptable when we're developing our cost models. When they get worse than that, then we spend more time redeveloping them. So we're going to call this plus or minus 10 to 15% error band. We're going to call that the natural error band of the cost model. And our objective with dynamic costing is to keep the cost results within that natural error band for the cost model. So you get a similar cost estimate, and that's really our objective. So for this first release, we've added dynamic costing to both die casting and machining. And I'm going to be showing the die casting here today. So this is the DFM concurrent costing software. So we're going to be analyzing a die casting. I'm going to specify a life volume of 75,000 parts, and we'll say it's a hollow block-shaped part, and it's going to be a big kind of flat part. So let's say it's 2 inches tall, 20 inches square, and the average thickness is 150 thousandths. So I'm going to select a cold chamber die casting process and this A356 aluminum for the material. So now the DFM software is set up. So whenever this second entry on the process chart has been selected, what's shown on the right is it's what's called the main response panel. And on this main response panel are all of the important cost drivers for a die casting, because that's the process that we've chosen. So right at the top of that response panel, we've added this new control, which is shown as dynamic costing with some off and on buttons, right? So when dynamic costing is turned off, what I'm seeing here are all of the important cost drivers for any or every die cast part. So if you're analyzing a die casting, these are all of the important cost drivers for any die casting. So now when I turn dynamic costing on, then I get presented with a much smaller list of responses. And what I'm seeing now with dynamic costing turned on is actually the list of important cost drivers for my specific die casting. So these are all of the important cost drivers for the part that I'm analyzing right now. So when dynamic costing is turned off, I see the important cost drivers for any die casting. When dynamic costing is turned on, I see the important cost drivers for my specific die casting. And this list of important cost drivers, it updates as additional information gets specified in my analysis. So for example, let's say my material cost, instead of being $1.23 a pound, it's actually $3 a pound. And I click calculate. So now, as a result of that information that's been specified, different inputs become important or lesser in importance. And let's say that my part volume, instead of being 82 cubic inches, it's about 50% higher. Let's say it's 120 cubic inches. And now when I click calculate, the inputs are changing as more information about the part gets specified. So that's the dynamic in dynamic costing. So the software is showing us what the important cost drivers are for this specific part. And in this case, it's showing us that the material cost per pound and the part volume are what's important. And it's showing us that the other drivers, the other cost drivers, the hidden ones, they're much less important. And that's why we've chosen this lightning bolt as the symbol for dynamic costing. So a lightning bolt is actually a symbol of knowledge and enlightenment. And that's what dynamic costing is providing. So it's providing knowledge about the important cost drivers for your specific part. And one important thing to realize here is that the hidden inputs, they're not being ignored when the software estimates cost. Instead, the software has figured out reasonable values for those hidden inputs, and it's used those reasonable values when it estimates cost. And because those hidden inputs are of lesser importance, those reasonable values are usually good enough to keep the results pretty well centered right in the middle of the cost model's natural error band. And we can see just how good the results are by completing a comparison analysis. What I'm going to do is I'm just going to make a copy of this analysis. And here in this copy, I'm going to turn off dynamic costing. And then I'm going to go through and specify, information for all of the inputs that were hidden. So for example, my batch size, let's say, is 12,000 parts, right? My maximum thickness is, quite a lot different. So it's 240 thousandths in thickness. My part volume and weight has been brought over from my dynamic costing analysis. My part projected area, let's say, is a little bit smaller, so it's 300 square inches. My outer perimeter is larger at 120 inches. And then the number of through holes on my part, let's say there's 5, and then the perimeter of those through holes is 15 inches. And my surface patch count, we'll say, is 250 surfaces. My tolerance is, most 2,007 inch per inch. I'm going to use the highest quality finish, and we have a 4-step parting line, and we also have some side pulls on the left and the right. So now this analysis that we've just completed is, it's quite a lot different than the last one that we did. Right? So when I click calculate, now I can see that my cost result is now $69.42. And that compares with my $71.10 result when dynamic costing was turned on. So the difference there is about $1.70, out of like $70. So that's just about a 2% difference. So you get a much simpler analysis to complete, and you don't sacrifice all that much in the accuracy department, And that's the kind of accuracy that we've generally seen when we've been testing out this dynamic costing feature. So now that you kind of have a feel for how this dynamic costing feature works, I thought we could look at some real parts and make some, these types of comparisons, right? So I'm going to just start a new analysis here, right? I'm going to import a CAD model. I'm going to analyze this housing. So we're going to be analyzing this part first. We're going to analyze it as a die casting. So it has two holes in it, and one of the holes is not in the direction of pull, and the other hole is kind of on the top or bottom of the part, depending on how you're looking at it. So it's in the direction of pull. So we're going to specify a life volume of 120,000 parts. It's a hollow block-shaped part. And my forming direction and principal axes are both in the y-axis direction. I'm going to choose this cold chamber die casting process, and again, that A356 aluminum. So now, with dynamic costing turned off, I can see all of the important cost drivers for any die cast part. Dynamic costing turned on, then I see all of the important cost drivers for this specific die casting. So what I'm going to do is complete this dynamic costing analysis of this housing. So I'm going to accept all of this basic data, right? So the plan efficiency, material cost, and scrap value, I'll accept all that. My part volume has been brought in from the CAD model, and we have one side pull on the left to create the hole that's not in the direction of pull. So that actually completes the dynamic costing analysis of this housing. I click calculate, and I get a cost result with dynamic costing turned on, $2.71. So now I'm going to be creating a copy of this analysis. And I'm going to answer all of the questions with a dynamic costing turned off. So that's actually a little bit, there's a little bit of effort involved in that. So what I've done is I've taken the liberty of completing that analysis ahead of time. So I'm going to just open up this completed file. All right. So here on this first tab is our dynamic costing analysis of our die casting. And you can see this is the analysis that we just completed together. And my cost result is the same, $2.71. So now I've created a copy of that analysis and specified all of the hidden information to see what kind of impact we have when dynamic costing is turned off. Right? So I've specified a batch size of 6,000 parts. I've accepted all of this information. My part volume has been brought over from my dynamic costing analysis. My part projected area, I've specified using the CAD model. So I've specified, all of this area that's shown in red, and I've projected it on the XZ plane. And that gives me a projected area of just over 40 square inches. Right? My outer perimeter, I've also defined using the CAD model. And it's, I've defined it as this perimeter that's shown here in red. And I've specified the through holes using the CAD model, right? So I've specified them as these two holes here shown in red with a perimeter of just over 7 inches. I've counted up surface patches on the part and typed in that 207 value. I've specified a tight tolerance, the highest quality finish, and a more than 4-step parting line. And then the side pulls on the left, that's been brought over from my dynamic costing analysis. So now, kind of clicking through all that, you can get an idea of how much additional effort is required, to do this analysis with dynamic costing turned off. So now my cost result, after going through that analysis, is $2.75. So that compares with my dynamic costing result of $2.71, right? So there's a 4-cent difference there. It's right around 1% of the cost of the part. So again, a significant difference in the effort and a very small difference in the cost results. Right? We can look at another part. So we're going to be analyzing this part that probably looks somewhat familiar to you. So it's the base of an office chair. Right? So you can see it's got these, kind of 5 spokes or legs on it. Right? We're going to analyze this as a die casting, and there's one hole that goes right through the middle of the part for the, the chair stanchion. So we're going to assume a 65,000 part life volume. I would classify it as a kind of rotational part that's thin walled, so we're going to call it a hollow cylinder. And the y-axis is going to be both the forming direction and the principal axis. So I'm going to choose this cold chamber die casting process again in this A356 material. So now, when the software starts, dynamic costing is turned off, right? And what we're seeing are all of the important cost drivers for any or every die casting. I'm going to turn dynamic costing on, and then we see a much smaller listing of responses. So that's the software is identifying the important cost drivers for this specific die casting. And the list of responses here is actually different than the last part that we looked at. It's a different part, and the software has identified different cost drivers that are important for this different part, right? So we're going to complete this dynamic costing analysis. So this basic data, we're going to accept all of that. The part volume has been brought in from my CAD model, part volume and part weight. So here is a difference, right? So our part projected area for the last part actually was not classified as an important input. In this case, it is. So we're going to define it. And I'm going to define this information using the CAD model. I'm going to define the projected area as the area that's shown here in red, projected in the XZ plane. And that gives us a part projected area of just under 97 square inches. And there are no, well, if I click calculate, now the software actually updates, this listing. Again, that's the dynamic part of dynamic costing. So now with that additional information specified, additional inputs have become important. So in this case, now my material scrap value of 50 cents a pound has become important. And we're going to accept that. My surface patch count has also become important. And in this case, it's quite a lot different than that. So we're going to count up surfaces on the part, and there's actually 78 surfaces. And I click calculate, and my screen has remained stationary, right? So now we can continue on, and there are no side pulls that are required for this part. Everything is in the direction of pull. So now my cost result for this part is $12.24, and that's my dynamic costing result for this particular die casting. So again, we're going to create a comparison analysis, and again, that takes some effort. So I've completed that analysis beforehand, so I'm just going to close this and open up my completed file. And I see my, on the first tab is this dynamic costing analysis that we just completed together with my cost result of $12.24. And now here I have, the analysis completed with dynamic costing turned off. Okay, so I've specified quite a lot more information here. So I've accepted all of this basic data. My part volume and projected area have been carried over from my dynamic costing analysis. But here I've defined the outer perimeter of the part, the number of through holes, the perimeter of those through holes. And I've counted up surface patches. I've defined a tolerance, my highest quality finish. And I've described the parting line as a canted or one step. And that results now in a cost estimate of $12.34. So that compares with my $12.24 for my dynamic costing analysis of the same part. So that's roughly, 10 cents out of $12. So it's, less than 1% difference. And that's the first release of our new dynamic costing feature for die casting. So for this release, we're going to be including dynamic costing for both die casting and machining. So the machining is a bit different and we're still working on it. So it's not ready to show just yet. But overall, we're pretty excited about this new approach of customizing this display of cost drivers to guide you to what's important for your specific part. And we hope that you find it useful. And there were a couple of other features that I wanted to talk about today. So in die casting in particular. So our process simulation for metal extrusion, it's actually been very well received. So we've received a lot of positive comments about it. So we're incorporating a process simulation into some of the other processes that are in our software. So we're adding one to die casting for this release. So if you click this process simulation button, then you are presented with this die casting simulation window. And you can see you get a kind of a representative picture of the die casting process, along with some values that are overlaid on the window. So you can see the cavity pressure and the various temperatures that the software is using to estimate costs. You can see the shot weight and the clamp force requirements. And this picture, as well as the values, they update depending on your analysis. So they reflect the analysis that you're doing. So suppose, you change to a 2-cavity tool, then you'll see a picture, with multiple cavities in it, as well as, the numbers have been updated, the shot weight, clamp force requirements have changed. And in addition to that process simulation, there's also a new process details report that we're including. And so in this report, it provides details and a breakdown of the die casting process costs. And the overall approach that we've taken with this report is to show you how the software's cost results have been calculated. And our intention with the report is that it would provide helpful breakdown information that would be useful whenever you're talking with a supplier, if you're negotiating or verifying prices or anything like that. So at the top of the report, you get some, overall part data. And then here you get a graphical breakdown of the die casting process costs. So you get the material cost as well as the die casting and trimming costs. And some of the numbers that are shown here are actually shown nowhere else in the software. So for example, if you wanted to get an idea of how much, the cost of melting the material, the energy to melt the material is, then you can see that on this graph. It's just over a nickel. So you can get some information about the die casting machine, so the name of it and the hourly rate information, as well as some of the parameters that are used in sizing the machine. So like the clamp force, the die opening, and the shot volume, all the required as well as the available values. So, for this chair base, for example, cast in a 2-cavity die, you have, it's going to require about 1,188 tons of clamping force, and there's 1,200 tons that is available on the machine. The die opening is just under 9 inches. That's what's required, but there's about 30 available. And the shot volume is just under 160 cubic inches. And there's roughly, more than twice that available on the machine. So you can get an idea here, that this clamp force is what's probably governing the sizing of this particular machine, because, it's kind of getting close to being maxed out. So you can also see some of the information that's shown in that process simulation window. So you can see the cavity pressure as well as the temperatures that are involved in the process. The software is using that to estimate costs. You can get a breakdown now of the die casting shop material. So you get a tabular as well as a graphical breakdown. So you can see the weight of the parts, the weight of the runner system, and you can see, percentages like the material utilization and the scrap material. So this information has been requested, quite frequently over the years. So we're going to be incorporating more of that information into the software outputs. You can see a breakdown of the die casting cycle time. You can see a breakdown of the tooling cost estimates for both die casting and trimming. You can see the breakdown of the material cost per part, and there's a series of other cost per part breakdowns that are shown. So you can see, for the die casting process, this is the setup cost breakdown. This is the process cost breakdown for die casting, the rejects cost breakdown for die casting, and the tooling cost per part breakdown for die casting. And we also show those same cost per part breakdowns for the trimming process itself. So the setup, the process, the rejects, and the tooling cost per part. So many of the breakdowns that are shown in this report, many of the values that are shown, they're actually shown nowhere else in the software. So they're all brand new, and there's a lot of information that's contained in them that's not available anywhere else in the software. And we've tried to show on the report exactly how the various cost results are being calculated. So for example, if you were interested in like the rejects costs for trimming, you can see exactly how the costs are broken down and how this cost result, which is shown in the software, how it's been calculated. And really that finishes up what I wanted to show you today. And I really hope that you find these new features very useful and helpful. Thank you.
All right, Brian, thank you very much for that great overview of the new dynamic costing feature that, as he said, we're very excited to release. We've just run out of time, so we're not going to take any questions today. Like I said, this has been recorded, and the recording will be sent out to you shortly. So I would like to take the time to thank everybody for attending. And again, if you have questions, please submit them to us through that questions option, and we'll get back to you right away with some responses. We're excited to get this new software to you, and hopefully you find a lot of these new features to be very useful. Thank you very much again for your time, and everybody have a great day.